Hello everyone, welcome to another new episode, and in this video we're gonna do this question. So yes, I'm sorry for the cricket noise, guys. I mean, I can't really do anything about that noise, but I'm really sorry. And I tried some background removing apps, but it was not working. So yeah, I'm sorry for that. So yeah, let's do this question. I'll wrap it up quick. And yeah, let's do this. A boy of mass 40 kilogram is on a water slide. This is a water slide, okay? Which slopes at 30-degree angle. So this is 30-degree angle, okay? And to the horizontal, the friction force up to the slope is 120 newtons. So this F, right? Wait again. This F is 120 newtons. Okay, and then calculate the boy's acceleration down the slope, and take the acceleration of free fall g to be 109.81. So let's see here. So there we have the normal force here, the W force here, the weight, the friction force, and then we have the downward force. So let's name this downward force some kind of a force, maybe like we could name it like Q or something. Q is not good. Let's name it A. It's a weird choice, but yeah. So this A we have to find, and then we have to find the resultant force because there's a friction force right here, and then to find the acceleration from that. So yeah. So let's do that. So first of all, in these questions, right, we can just use the normal, just straightforward equation, like A equals to W sine theta or something. But yeah, we're not gonna use that. We're gonna actually explain how that happened, right? So we have normal force right here. Okay, normal force right here, and then we have force right here. And then let's break down the W force. So as you can see, the W force change direction, because the weight force should be like this, but now it's like this. So that's the difference. So we have to find the direction change. So we have to split up the W weight force into a vertical and then a horizontal vector. So let's do this, right? So the easiest way to do this for me is drawing a coordinate, y-x coordinate. Right, so y is, I'm sorry if this is really messy. Well, it might be messy, but yeah. So we draw that coordinate system, and then what we do is like along this line, this is gonna be the A force right here. And I just draw a perpendicular line like this, and it should be a triangle. So this is like splitting up the force, right? So this force right here is gonna be Wx vector, and this force right here, is recognized, is gonna be a Wy vector. So we just split the force. We just resolve. I think that's the right word. To resolve the W vector into two vectors, right? So as you can see, the Wx vector is same as A, so we define A. So we can use simple trigonometry right here. So it's a right angle triangle. This is 30 degrees. So we can do, we draw the big triangle here, and then we can find this angle right here. And that angle is gonna be, this is a 30, 90, and should be 60 degrees. So it's 60 degrees and this is 30 degrees, right? So just like doing like that, this angle is 30 degrees. So if we can find A using trigonometry, we know the W, we can find the W, right? So, and then Wx or A gonna be equal to this and this, which is gonna be sine W sine 30. So that's how we get the equation this time. So now you just use the equation here. So this is sine 30, so sine what's happening with sine 30 is equals to the opposite length, which is the A, and W. So we can find W by multiplying the mass and the acceleration here. So the 440 kilogram multiplied by 9.81, and that will get 392.4 newtons of force. So we get A, we just do W sine 30, so it is 392.4 sine 30. Why did I write a 3? 30. So I just use a calculator for it. 392.4 sine 30. And make sure I'm using degree mode, and yes, should be 196.2 newtons of force. So the boy is experiencing 196.2 newtons of force going this way. Then now let's find the resultant force. Right? So let's find the resultant force. Yeah, I will just write it RF, resultant force, which is we have to subtract 120 from 196, so this would be, okay, 192 minus 120, and that would get about like 72.2 newtons of force, right? So now we just need to do is find the acceleration of the boy. So we can use the Newton's second law equation, F equals to ma. Is gonna be equals to F over m. F, and in this case, it's gonna be 72.2, and Newton's mass is gonna be 40 kilograms, right? Yep. And then we just divide this. It's about like 1.8 meter per second square. So the point will accelerate at 1.8 meter per second square. So yeah guys, so this is gonna be the end of today's episode. So I'll see you guys tomorrow. Goodbye.